Hello, in this video I'm going to go through part B of question 1 on Map 2011. So here we have a rectangle which has perimeter P and area A, and we want to know which of these inequalities must P and A satisfy. Okay, so let's have a think about what P and A are. So if this is my rectangle, then we know the opposite sides have the same length, and so in terms of x and y, P and A would be 2x plus 2y and x. And we want to relate P and A, so let's use these two equations to make one equation which relates P and A, for example by getting rid of the y. So if I use this second equation, then I can rearrange to get y is equal to a over x, and then I can substitute this into our equation for P, and this is what we'll end up with. And so let me just multiply everything through by x, so we don't have any awkward fractions to deal with. And this is the equation that we get, which relates P and A. So now we have this equation, how can we get some inequalities out of it? Well, if we're looking for inequalities, I guess one thing we could do would be to look for a maximum. So if I rearrange this for A, let me call this star, then I could maximize A, and I know every value of A would be less than or equal to that, and that would give me an inequality. Or I can also note that this is actually a quadratic in x, and well, another way we can get inequalities out of a quadratic would be to look at the discriminant, right? Because we know x is a root to this equation, and it's real, so we can't have a negative discriminant. Okay, so let's look at the discriminant first. So we can see that this is equal to 0, and therefore x is a root to the quadratic 2x squared minus px plus 2a, and we know x is real because it's representing a length. And well, if this quadratic has real roots, then we must have its discriminant being greater than or equal to 0. And okay, what is the discriminant of this quadratic? Well, that's just going to be, so our b is going to be minus p, so b squared is p squared, then minus 4 times 2 times 2a, so this is the discriminant. We need it to be greater than or equal to 0, and if we rearrange this, we see that p squared is going to be greater than or equal to 16a. Okay, what about if we maximized a? Well, if we just maximize by differentiating a with respect to x and setting the derivative to 0, because we know at maximums the derivative is 0, so that gives us that a half p minus 2x must be equal to 0, and this rearranges for x equals to a quarter p. And so we know that a is greatest when x is equal to a quarter p. So the maximum value of a is going to be, well, if we just substitute a quarter p for x in here, then what we have after we simplify is that the maximum value of a is 1 over 16 p squared. And because this is the maximum value of a, then a is always less than or equal to this. So we get that a is always less than or equal to 1 over 16 p squared. So p squared is always greater than or equal to 16a, just by multiplying both sides by 16 there. So we've actually got the same inequality out of with both methods, and p squared greater than 16a, well, that's answer C.